Yo, 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 this is Mr. O. Yo, 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 Mr. O. And today we're going to learn about solving absolute value equation and inequalities. Basically, we're going to try to review learning solving absolute value equation and inequalities, okay, with the relation with the compound inequalities. All right, so moving on. So there are three sets here. One is the equation portion, solving absolute value equation, wherein they're equal to a constant. And what we just need to do there is just set the x equal to negative a and set the x equal to positive a, or the number, the constant. And also we have the greater and less than. When you are given absolute value of x less than means you're gonna have an end problem wherein it's going to be like this. Or you can split them to two and just separate them with the word end. I'll show it to you in a while. And absolute value inequality, when x is greater than, this is a greater, so the or problem. And that's why you have or there. And split them into one will be a positive and negative, but you have to flip the inequality. Okay. I'll show you a good example for each kind. Okay. So let's go ahead. First here, solve the equation below and graph the solution. You have number one, x absolute value of x minus 3 close plus 1 is equal to 5. You have to remember that before you decide on solving it, you have to understand what is given. On this given here, I have an absolute value here and a 1 and an equal to 5. Before you do something, you have to combine the like terms. So I need to move the 1 to the other side by subtracting it by 1, subtracted by 1. So that gives me an absolute value of x minus 3 is equal to 5 minus 1 is 4. Now, in this case, we already isolated the absolute value, and that's what we like to happen. And from here, going back to what I showed you here, if you have an equal sign, you split them in two. One is negative, one is positive there. So here, if I split them in two, one will be x minus 3 is equal to negative 4. X minus 3 is equal to positive 4. If you notice, the absolute value is gone. And here, you're just going to solve for the x. You're going to add 3 here, add 3 there. So therefore, x equal to negative 1. Excuse me. Add 3 here, x equal to 7. So the solution set will be negative 1 comma 7. And the graph is negative 1, 7. No need to connect. No need to do anything. Just plot the point. Kaboom. Next. You have a 4, absolute value of x plus 2, close minus 6 equals 14. Again, we need to combine the like terms. We need to isolate this portion here and get rid of the negative 6 and the 4. First thing you have to do is you have to move the negative 6 by adding 6 on both sides. That will give you 4. Absolute value of x plus 2 is equal to 20. Now you can divide everything here by 4 by 4. That will give you absolute value of x plus 2 is equal to 5. Again, you split them into two. One is x plus 2 is equal to negative 5. The other one is x plus 2 is equal to 5. Work it out, minus 2 on both sides here. That gives you x equal to negative 7. Minus 2 here, x equal to 3. So the solution set is negative 7 comma 3. The answer will be, or is negative 7 and positive 3. Kaboom. Very easy, right? The next one here is absolute value of inequality. This time, if it's less than. If it's less than there, guys, it's an end problem. When you say end, you will find the intersection. When you find the intersection, you graph them and find where they intersect, they overlap the graph. Okay, and let's do it here. Absolute value inequality. There you go. So here, if you notice, it's an absolute value with a less than there. So it's going to be an end problem. So what we're gonna do here is this one. Split them into two. 2x. You know what? I'm just gonna write the answer, the work over here in the bottom. 2x plus 6 less than 6. And write the word end. 2x plus 6. Watch here. I'm gonna flip the inequality to become greater than, and this become negative 6. That's all you have to do. Okay, so work it out. Minus 6 on both sides. 2x greater less than 0 divided by 2 divided by 2, x is less than 0. And minus 6 minus 6, 2x greater than negative 12 divided by 2 divided by 2, x is greater than negative 6. So when you graph that one, the x is less than 0, the 0 is open, it's going to the left. Next is negative 6 right here, is open also, is going to the right. Did the pink and red graph intersect? Yes, they did. They intersected over right here. So the graph will be this darkened portion, the blue one here. And the solution set will be right this one here. Okay? Easy. Kaboom. Next. Absolute value of 2x, absolute value of x minus 2 plus 7 less than or equal to 10. Again, you want the absolute value to by itself, so move the 7 to the right by subtracting 7 there. You have now absolute value of x minus 2 less than or equal to 3. Since this one here is less than, we're going to do the same thing like what we did in number 3. So x minus 2 less than or equal to 3. And because it's less than, x minus 2 greater than or equal to negative 3. Solve it. Add 2, add 2. X less than or equal to 5. And plus 2 here, plus 2 there. X is greater than or equal to negative 1. And this is my solution. And if we graph them, the 5 is right here, is close because it's equal sign there, and it's going to the left. And the red one, negative 1, is close also. It's going to the right. Did the red and blue graph intersect? Yes, they did. They intersected right here. Excuse me. At some point, you can erase this portion here. That's fine. Or you can leave it blank as long as you darken the intersection. Okay. So absolute value of inequality this time with x greater than. If it's greater than, it's an or problem. Or we combined, or we put them all together. Okay. All right. So again, solve the inequality here. This time here, the absolute value is not by itself. There's a negative 9 then. So I have to move that 1 by adding 9, adding 9. That will give me an absolute value of negative 6x greater than 21 plus 9 is 30. Now, since this one here is greater than, so I know it's an or problem. So I'm going to do the same thing. I'm going to split them into two. Negative 6x greater than 30. I just copied it. The other one is negative, oh, don't forget the word or. Negative 6x less than negative 30. Divide everything by negative 6, negative 6. So therefore, x, this will flip over. Negative 5. Or you got to divide again by negative 6 here, negative 6 here. Since you divide by negative, so it will flip over 5. So this is your solution set. The graph, negative 5, open to the left, 5, open to the right. And that's the answer. That's a complete graph there. All right, next. 9, absolute value of x minus 8 minus 10 greater than or equal to 26. And I have here absolute value of x minus 8. I need to get rid of the 9 and the negative 10 by adding 10. Move this one to the other side. So I'm going to add 10 here, add 10 there. 9 is absolute value of x minus 8 greater than or equal to 36. Divide everything by 9. So therefore, absolute value of x minus 8 greater than or equal to 4. After you isolate the absolute value, this is the only time you're going to split them. So x minus 8 greater than or equal to 4, or because it's greater than, and x minus 8, flip it, flip also the sign. Add 8 on both sides, x greater than or equal to 12, or add 8 on both sides, x less than or equal to 4, and the answer is right there. Graph them. The 12 is right here. It's close to the right. X less than or equal to 4, close to the left. And that's the graph. Kaboom. Okay. So at this point, I need you to pause, copy the question here from 1 to 6 on the practice, and try to solve them all. Okay. You need to show your work and try your best. Okay. All right, there you go. Good job, guys. So please double check your answer. Here is the answer key for that problem. Okay, there you go. I hope you learned something on how to solve absolute value equation and absolute value inequalities using compound and an or type of problem. Kaboom.